All right, hello everyone. This is John, and in this video today, I want to demonstrate some of the precautions or things that one needs to consider when dichotomizing a continuous variable. Dichotomizing a continuous variable really involves taking a variable that's measured on a scale and then putting that scale into groups. So for example, you might put individuals in a high group, a medium group, and a low group. And in this example, I'm going to show what happens when you split a variable into two groups. So why did I want to talk about dichotomizing continuous variables and why I wanted to make this video is because that there's certain problems that someone can run into, and they need to consider these things before they start analyzing the results based on grouped variables. So for one, when you start dichotomizing a continuous variable, you can lose a lot of information that is already present within your data. So if you're losing information, you're going to lose statistical power. And in many cases too, when you're dichotomizing a variable, splitting it into groups, a lot of times these groups are very arbitrary. Someone might have the idea of splitting a group into two groups, like two smaller groups or three smaller groups. But in many cases, unless there's a strong hypothesis to back up why you are doing it, in many cases, it's not necessarily going to be a good idea. And if it's going to be arbitrary, you're going to increase the probability of what is called a type 2 error, just meaning that you might fail to detect real differences in your data. And a more obvious thing too is once you start splitting a data set into smaller groups, those smaller groups are going to have a smaller sample size. And in an example like this data set I have here, I only have 20 subjects. So once I start splitting this one variable, it's going to lead to a smaller sample size in each group. So the first thing I want to do is just quickly explain the data set here. I have one variable, which is job satisfaction, which is my dependent variable. And then I have my other variable, which is extraversion, which is my independent variable. So let's quickly pop up this window. Job satisfaction is measured on a scale from 1 to 5. 5 being high job satisfaction, 1 being low job satisfaction. And then I have my extraversion scale measured on a scale from 1 to 10. 1 being low extraversion, probably more introverted, whereas 10 is high extraversion. And the idea here is, let's say you're working with someone and they want to split the extraversion variable because they have a hypothesis is that highly extroverted individuals should have higher job satisfaction, whereas low extroverted individuals should have lower job satisfaction. And the way they want this variable dichotomized is by doing what is called a median split. So I'll demonstrate that right now. So we're going to take our extraversion variable, go to Analyze, Descriptives, Frequencies, and we are going to put it into the box, click Statistics, and grab that median. And we're going to use this median value to now draw our arbitrary dichotomized groups. Click OK. So of course we have 20 valid cases, and the median across this extraversion scale is 6. How individuals choose to dichotomize or split groups, like I said, could be completely arbitrary. But let's say in this situation, someone wants a median split. We're going to take this median, a value of 6. Anyone below 6 is going to be grouped into group 1. Everyone who is 6 and above, we're going to group as group 2. So let's quickly do that. We're going to go to Transform, Compute. Our new variable is going to be called median split. And what we're going to do is our first group is going to be given a value of 1, and that is going to be everyone who is below a value of 6. Click OK. And then let's just do the second group now, a numerical expression of 2. We're going to then once again go into extraversion, and now it's going to be everyone who's greater than or equal to 6 is a value of 2. Click OK. So now what we have is our median split variable. Let's just clean it up a little bit. So we have our median split variable now, which is 1 being low extraversion and 2 being high extraversion. And what I want to demonstrate here is that we're going to compare the two variables. We're going to compare if you left extraversion as a continuous variable and if you decided to group extraversion using a median split and how they'll affect the results on job satisfaction. So first thing I want to show is a correlation. We're going to go to bivariate. We're going to include job satisfaction, extraversion, and the median split just to show how the results could vary depending on how you choose to group individuals. So looking at the correlation table, we have job satisfaction, and it's significant when it comes to the extraversion scale. So when you have the extraversion scale left as a continuum, there is actually a positive correlation going on between job satisfaction and extraversion. On the other hand, when we look at the median split variable, it is no longer significant. When we chose to group individuals, almost forcing groups amongst all of them, really two groups, we're losing power, we're losing information, and what we're actually doing here is potentially creating a type 2 error. Of course, there's more analysis that should be involved in this, but really we went from having a significant result to having a non-significant result. So I really wanted to emphasize this in this video because in many cases, individuals might completely bypass the continuous variable, the raw data that they've collected, and start grouping individuals and find that there is no relation between individuals who are grouped. So if we did the continuous variable, we could reject the null hypothesis and actually say that there is a difference between highly extroverted individuals and job satisfaction. But if we had our median split, we would not see this. I want to do a few more results just to emphasize this point a bit more. Let's say instead you decide to do a regression, linear regression. So with job satisfaction is our dependent variable. In our first analysis, we want to use extraversion. The continuous variable, we run it, and when we look, our result is indeed significant, just like the correlation table. But when we left it as a continuous variable, looking at the R-squared value here, it's actually explaining 20%, 20.5% of the actual result that is taking place here. The explained variability is 20.5%, which is pretty good. Now, let's run the same analysis. Let's kick out extraversion and use our median split variable to see how much the R-squared is being explained now. So of course, just like the correlation table, the result is not significant. But when we look at the R-squared value, it's only it's actually 6%. 6.6% of the R-squared value is being explained here. A lot less than before. And as I was mentioning previously earlier in this video, is that you're losing information, you're losing statistical power, and unless you have a strong reason to why you want to be grouping individuals using, for example, a median split, I would heavily precaution against it because you're going to lose a lot of results in your data. And finally, let's just do some graphs just so we can make some comparisons as well. We'll do a scatter, simple scatter. So in our first one, we'll have job satisfaction on the y-axis, extraversion on the x-axis, and let's set markers based on our median split. All right, so here the idea is we're going to measure job satisfaction and extraversion, and then we'll have all the individuals color-coded based on the median split. We can click OK. And just like our, let's open this up a bit bigger. We'll add the line, the regression line. So here you could see in this graph here is that we have our line here, and you could see on one side of the line we have a mix between low extraversion and high extraversion, and on the other side of this line of fit we have low extraversion and high extraversion as well, meaning when you're adding a line of fit and you're using the regression model, there's a lot being explained here, 20.5%, but the median split does not necessarily reflect the values that are found in the continuous variable. So once again, let's run this graph one more time. Run the graph one more time. And this time we're going to switch out the variables. We'll use extraversion to set the markers, and we'll use the median split on the x-axis. Here's the new result. Let's quickly get that regression line in there. And once again, just like the regression analysis we did, it's only explaining 6.6, and right away the slope, it's not as steep, it's not as explaining as much as the results as what we were finding in the continuous variable. I wanted to demonstrate this so people have a bit of an idea of what they could be getting themselves into when grouping variables. Also, I'm going to leave a reference within the description below on an article that provides a bit more detail on the problems dichotomizing continuous variables and methods for analyzing data to see whether you might run into these problems and whether you should be dichotomizing your variables at all. Thank you for watching. If you have any questions or any suggestions on how to potentially improve these types of analyses or taking certain protocols into account, please let me know, as I'm always trying to build my repertoire when it comes to statistical analysis. Thank you very much.